trying to make the point that we've already done this when we found the distance from that point to the origin. The length of that vector is going to be the same as the distance between the point and origin. So we got the square root of 200, or 2 times, sorry, it's 10 times the square root of 2. Okay, so here's 0, 0, 0, and we're going to the point 6, 8, 10. We will do a lot more with vectors in chapter 13. It's just if you already know what one is, then we also have to do that in chapter 13. Okay. In rectangular coordinates, the equation of a sphere is given by what I have written down here. So again, if you could kind of search back into your memory of college algebra or pre-calculus class, you should have learned about circles. And circles had a very similar equation. We've just added a third dimension, but there's actually an even better way to think about it. And I do wish that I had my gold here. But, picture a sphere, okay? A sphere is a ball. And so, suppose this end of my ruler is at the origin, okay? It's now sticking out and it's ending at some point. If I move my ruler over here, did I change the length of the ruler? No. Okay, so this point is the same distance from the origin as the point over here. And if I move it here, I still have to change the length of the ruler, and so the point at that end is the same distance from the origin as my other 2 points, et cetera, et cetera. And so I could move this ruler anywhere, and if I had a whole lot of time, and I somehow was able to put a little point of light where I stopped it, I would form a sphere from all the different directions that I'm moving the ruler, okay? So what is the distance formula? The distance formula is difference between x's squared plus the difference between y's squared plus difference between z's squared. And that distance stays the same. It's equal to the length of my ruler. So this is actually the equation of a sphere. You write down the distance formula and you set it equal to the set distance that is the radius of the sphere. In this case, it would be the length of my ruler. If I squared both sides, I would get r squared equals x1 minus x2 squared plus y1 minus y2 squared plus z1 minus z2 squared. But there's one other adjustment I need to make. To have any specific sphere, I need to have a fixed center. So I started my discussion with my ruler having this end at the origin. Your center doesn't have to be the origin. It could be any point, but the center will be some point. So it'll have some coordinates, h, k, l, whatever you want to call it. What did I call it up there? I called it j, okay. What's a j? All right, so here's some point, h, j, k, and here's some radius. And again, if I move that same radius out from that point, I will end up forming a sphere. Okay, so that's really where this equation comes from. So suppose a vector has initial point 1, 2, 3 and length 20, find the terminal point of your vector. And then the second question, why can you not give me a definite answer to the task we were just asked?
Because you can supply direction.
Exactly. Thus, the solution set forms a sphere with center 1, 2, 3, and radius 20. Okay, so if you were just asked this initial question and you were answering like a true mathematician, it says find the terminal point, and you thought about it a bit, you'd say, well, wait, there's a whole bunch of terminal points. So they want to know how to get terminal points, so it'll be 400, it'll be the set of points. So the answer to number 13 is the set of points that satisfy x minus 1 squared plus y minus 2 squared plus z minus 3 squared. Okay, that's the answer to problem number 13. And is everybody, where did I get 400? Where did that number come from?
20 squared.
20 times 1, right. Okay, so answering as an upper level math student, we're not just gonna say, I can't answer that. Okay, which, I mean, that is an answer, but a better answer from an upper level math student is the one that we just wrote down in box. Okay, it's the set of all points, because it's not just any point in space. For it to fit this criteria, it has to be on the sphere, and that's the equation of the sphere.